All right, so let's get our notebook started with, after we did the silent board game, which is always fun, we want to get into CPM 3.1.2. Our focus again is on patterns, graphs. Please stop doing that. Equations and function tables. Great. So we are starting at 310. All right. The one thing I like about this particular book is it gives you like a large word problem to work through. And for this one, it's no different. So remember how we talked about yesterday, we're looking for a pattern. Well, we can find them sometimes and even in trees. So John found the data in a tree table about his favorite redwood trees. He wondered if you could use it to predict the height of a tree at other points of time. Consider this when you analyze the data and answer the questions below. So what we need to do is this. We need to make an X and Y table. So let's do it. So don't forget, when making, oh, it's frozen. When making your X and Y table, hold on just a second. When making your X and Y table, you want to make sure that you have your 0 involved, right? Hold on. Oops. Here we go. Bless you. All right, so we need to have on the X's, this is 0, 1, 2, 3, 4, 5. And remember, this is like years old. This is the height in which the tree is. So we don't have a 0 yet, but we have year 3, which is 17. Year 4 is 21, and year 5 is 25. Now what they are asking you is how much did the tree grow each year? It's asking for the rate of change. Yeah, Nathan.
4 feet.
Yeah, 4 feet a year. And it's plus 4 each time. So what is year 2 going to be? Yeah, Bishop.
13.
Perfect. Who's got year 1? Yes.
9.
Yep. Who's got year 0? Yeah. Good. See, you guys have already have it. What are we going to do for the next, let's say, what about year 6? Yeah, Jonathan.
29.
Did you say 20 or 29?
I said 29.
Okay. I'm sorry, I just didn't hear you. All right. So we've got this part down. We fill in our X and Y table. How are we going to get the equation? So we have the table. We need the equation. How am I going to do that? Marley.
That you take like the M
Yeah. So this is the M, right? The rate of change is plus 4. Let me write the equation. Y equals mx plus b. So now we know it's 4x. But where's our b? Who remembers where our b is? Yeah, Tony.
isn't it 0?
Yes. Our B is the 0 and 5. B, or I'm going to just say y-intercept. Okay, so our B is plus 5. Awesome. Guess what? Do we have, Ellie, do you have a question? Okay. So now we have our equation. Now the next question they're going to say is how tall was the tree when it was planted? It was planted, 7 years. We know who's got 7 years? I'm not really reading this as I go. Who's got 7 years? Yeah. Good. You are absolutely right. So year 2, year 7, we've got those. Estimate the height at 50 years. Do you know how you would do that now that you have an equation? Remember, the equation is an x, right? So, watch. Sorry. Watch this. So you have y equals, we want to know how tall it's going to be at 50 years old. So you have 4 times 50 plus 5. So y equals 4 times 50 is 200, right? Plus 5. So it's going to be 205 feet tall. That's all you have to do. You just plug it into the equation and solve it. That's it. Now, can we graph this? Yes. Okay. Let me show you this tool, though. This could be fun to play with because it obviously is Desmos. I don't always do that. We do need to learn how to do our gig. So we have this cool Desmos blah, blah, blah here. See? Boom, boom, boom. So we can write our rule, which is y equals 4x plus 5, right? And there it is. And so this is 0 and 5. 1 and, what do we say, 9? Perfect. Do you see, the Desmos is always fun. This is 3 and, yeah, that's it. Or 2. 3 and 17. 2 is 13. I just want to make sure that I'm right on 4 and 21. If you guys want to go into Desmos, you are more than welcome. 6 and 29. See how it crosses each little thing? And then you can you plug in that? No. So 0 and 5. Oops. Oop, not 2. Uh, 1 and 9. See, you can change it as we go. 2 and 13. Perfect. This is fun. I guess. I don't know. Do you guys think this would be fun? So you can fix this all day, every day, and adjust it. You can also send it to me in an email, or you can load it into Canvas. A couple of you have done that before. Okay, so we've got this. Can you use the graph to predict what it would be after 20 years? Well, yeah, because look. Hold on, let me move. Here's year 20, and it's crossing right here. Hold on. It would be 85 feet tall. Is that cool or what? All right, I'm sorry. Sometimes I'm like, yeah, that. Can I put a pin in it? I don't know. But anyway, there you go. So that's that one. Now, oops. All right, so let's move to 3-12. We did 3-11. let's go to 3-12, which is our last one. Because we spent so much time doing the silent board game. I know. I love the silent board game. So much fun. Oops, you can't see it. Okay, 3-12. Here we go. John is still not satisfied. He wants to be able to predict the height of the tree at any time. Oh, but we did all this one. We had year 0, the first, the second. We did the silent board game. And we did the 50th year. Oh, we really got crazy. But let's go back and let's do a graph of this. So let's go back, instead of doing 3-12, which we already did, let's make a graph, shall we? And we are going to graph 4x plus 5. Okay? 4x plus 5. Now, what we do want to do is we want to make a whole page graph. So I'm going to get this as much in the middle as you can on your graph paper. Hopefully you're using graph paper. All right. So when taking a look at our equation here, we always start with the 0 and the 5. That's our starting out point. So I'm just going to go up 5. 1, 2, 3, 4, 5. Dot. It's 0 and 5. Okay. So we're going to start here. Start with the 5. Okay. Now the next thing we need to do is we need to go over to the slope, because it's telling us that we're going to either go over 1 and up 4 or up 4 and over 1. I like to go up 4 over 1. So I'm going to just do this to show you. Up 4, 1, 2, 3, 4, and over 1. Like that. Second dot, which is 1 and 9. I'm going to do it again. I'm going to go up 4, 1, 2, 3, 4, and over 1 here. Questions? And then once I do this, this is 2, what did we say? 2 and 13. Perfect. And then when you draw a straight line, you're making it through a bunch of different points. Now, if you look at this line, it's a positive slope, right? What are some things you notice about this line? Well, it's a positive slope. That's one, right? Anything else? It's kind of steep, isn't it? It isn't like going this way. It's kind of like up there. So this is a steep slope. Okay. Notice that you don't, I want you to notice this. See how I put the 2 points, like the 2 arrows here? You should be doing that. Make sure your line is straight so you can see where it's going. All right, did everybody graph this? Okay. All right. We are done. You may get started on your homework. Good job, everybody.